So in this case, we are going to consider our November 2023 exam revision for our mathematics grade 10. This is important that we do make a revision as we are preparing for the exams which are ahead of time. So this is our paper 2 as we had the paper 1. So we shall also try by all means to work with the paper 2 for November 2022 exam also, so that we just see how questions are given. They're just similar questions. So you just have to revise as many question papers as you can. You just see that they are just similar questions. So make sure that you go through your instructions as we are given. These instructions, they are for you to read. Where necessary, answers should be rounded off to 2 decimal places unless stated otherwise. So that is the major part in terms of rounding off your answers. So rushing through our questions, question number 1. We are given the maximum temperature in degrees Celsius at 20 tourist resort centers. We are given the temperatures in degrees Celsius from 20 different resort centers. Were measured and recorded after that. This is the information that is given. The results were recorded in the table below. On 1.1, write down the median temperature measured. The median, the middle value, when these temperatures are arranged in order of size. And we can see that they are actually in order of size 22, 23, 24, 25, 26, 28, up to the maximum, which is for the of all the temperatures that were recorded. We can see that they're already in order of size. So first, we need the median position. There are 20 tourist resort centers. So first, let us find what? The median position, where the median is going to be situated. And we do understand this is half of n plus 1. This is ungrouped information. We must use n plus 1. For the grouped information that we just say, we use half of n, half of way up. We are just assume that it is going to give us exact value. But for dealing or working with ungrouped information, do not forget to use the n plus 1. So that is half of them. Distribution, which is n, the total number that we have, which is 20. So that's 20 plus 1, which is 21. So that is it, guys. Half of 21 on your calculator. That is where we need this value, which is actually 10. It's going to be 10,5. So meaning to say, we have to count 10,5. This is the position. It's the 10,5th position where it is to be located. So as you have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10th value. But the number that we need is 10,5. 10,5. So how do you simplify when it is a decimal like that? You take this digit, add to the next digit, then divide by 2. So meaning to say, the median temperature in this case, considering the exact answer now, you add the temperature that is at 10. Remember, this is 10,5. So you take at 10, the digit that is there, you add to the next one, the 32, then you divide by 2. Whenever you're given a decimal, whether it's 10,2, it's 10,3, it's 10,75, whatever that you're given there, you have to take that digit, add to another one, divide by 2. So that was going to remain as 32. It was 64 over 2, which is 32. That is 32 degrees Celsius. That is the median temperature. So that's 32 degrees Celsius. Remember, the median, you can even write this as Q2. That is the median value that we are going to have. So moving on to another question, it was to determine on 1.2, 1.21, the mean temperature, the mean. So remember that the mean, we can write this one in short. For ungrouped information, it is written as X bar like this, where it is equal to the sum of the X values over the number of terms. When you're talking about the sum, or you're talking about the sum of these, where we add 22, 23, 24, everything up to 40. So you're going to add all these values up to the last digit. You are going to obtain 629. Just use your calculator, guys. Add everything that you see. It was going to give you 629 over 20. So divide these two. The 20, remember, these are the number of the resort centers that we are given. Remember, you're told that there are 20 in total. If you add these numbers, you're going to see that there are 20 that are on the table there. So that was going to give us 31.45 degrees Celsius. That is the mean temperature that we are having, 31.45. Then we move on to another question, which is 1.2, to the range. That is the temperature range. Whenever you talk of the range, it is always the maximum value minus the minimum value that we are given. So it's maximum minus the minimum. As we can see from the table, this is the last digit. That is our maximum, which is 40. The minimum value which was recorded, that is the first digit that we see, which is 22. So the difference is called the range. So in this case, we are dealing with temperature. So that is the temperature range, which is going to give us 18. That was 18 degrees Celsius. So it's just the difference between maximum and the minimum value. Then the interquartile range. The interquartile range. Remember, for you to have the interquartile range, there is no way we are going to need the upper quartile minus the lower quartile. That is, we are dealing with the upper quartile minus the lower quartile. The difference between these two is what is going to give us the interquartile range, whereby the upper quartile range and this lower quartile range has to be calculated. So Q1, the lower quartile range, is equal to what? Remember, this is a quarter of the distribution. That is a quarter of n plus 1. We are talking about the position of this Q1. Where is it going to be situated? Which position is it? So remember your n, the 20 there, the number of the total, that is 20. So a quarter of 20 plus 1, which is a quarter of 21, 1 over 4 times 21 was going to give us, that is the decimal that you're going to have there, 21. Divide by 4, you are going to obtain something like 5.25. That's 5.25. This is the position that we are to obtain Q1, 5.25. So as you can see, there's a decimal. So you have to count 1, 2, 3, 4, 5. This is the fifth value. Remember, we are talking about 5.25. So we need the fifth value, just like what we saw here. It was 10, something. Then we had to take the next digit. It is the same thing. We are supposed to use the fifth value, but it is having a decimal. So you must also add the next digit from the fifth value that you are here at 26. You add the next value that you are given, then divide by 2. So meaning to say the exact value of Q1 was going to be 26 plus 28. You divide by 2. In every case of a decimal, you take that digit at that position, and the next one you divide by 2. So that was going to give us 27. This is Q1. The same thing on Q3, which is our upper quartile. Its position first. Its position. We need its position. This is 3/4 of what? Of n plus 1, which is our total distribution. So n, remember, is 20, the total that we are given. So 3/4 of 21. 20 plus 1 is 21. So 3/4 of this was going to give us 15.75. This is the position that we are dealing with. So we need to count up to 15. So remember, here we were at 10. At this point here, it was 10. So we are going to count from there. That is 10, 11, 12, 13, 14, 15. So remember, there is a comma there. 15, 15, this. So you must take the 15th value, you add it to the next one, just like what we saw on the previous case, where there's a comma, you add to the next one. So meaning to say the exact value for Q3, we're going to add these two values, 36 and 37 together, divide by 2. So that was going to give us 36,5. So this is what we have. Now bring these values now representing the upper quartile, 36,5, subtract the lower quartile, which is Q1, which is 27. That was going to give us the interquartile range, which is 9,5. Remember, we're talking about the temperature there. So that is 9,5 degrees Celsius as our temperature range. So questions can be like that. Then from this information that we are given, the question now is for you to draw a box and whisker diagram to represent the data above. This information that we have, represent it on a box and whisker plot. Remember the box and whisker plot, it needs the 5-number summary in order for us to have it. We need the 5-number summary, the minimum value. Remember that. The minimum value is needed, whereby the minimum, we can see it from our table. This is the first value that we are given, which is 22. We need the median, which is our Q2. Remember the median, we calculated this. We got 32. Then we need Q. Okay, we left Q1. We're supposed to start with Q1 before this, guys. Remember, in this order. Let us have it in that order. Q1, which is our lower quartile. Remember, Q1, we got this 27. So this is degrees Celsius. Then Q2, which is our median. So this is our median. Remember, our median, we calculated this. It was 32 degrees Celsius. Then we need the Q3, upper quartile. That was 36,5 degrees Celsius. Then we also need the maximum value. And the maximum value is on our table here. The last digit that we see there is what is 40. So these are the 5 values which are to be represented on your box and whisker plot. Remember your box and whisker plot, guys. All right. So we are supposed to have these 5-number summary represented. Each and every part is supposed to play a role. So how is this going to play a role? So I'm just going to have a sketch, but you're supposed to have the exact thing, guys. But as for me here, I'm just going to try and draw a sketch. So we're just going to have a line, of which this one is not important, but let's just have our line, which is representing our values. Then we just need a box here, all right, which is a rectangle. So if we are to take a rectangle, unfortunately, all right, fortunately is there. I thought that unfortunately we do not have, but fortunately we have. So this is a rectangle that we are going to need in our presentation. All right, let's just try and put it somewhere here. All right, so this is our box. Then we need these whiskers. All right, so we're going to take to the minimum value. All right, so it's going to be taken to the minimum value. Then in the other one is going to be taken to the maximum value. So I'm just going to present how it was going to be like in terms of your value. So this is the minimum value, which is going to correspond to what? To 22. Then we talk about Q1, which is our lower quartile at the beginning of the box, where the box is beginning there. That is 27. Then the median value in between. So that's 32. You can just say maybe 32 is somewhere here. That's our Q2, which is our median. So it was going to correspond at 32. Then Q3 at the end of the box here, that is where Q3 is, which is 36,5. So you're going to have 36,5 representing Q3. Then the maximum value is the one at the end of the whisker there, which is the 40. So these numbers are supposed to be represented as we understand our box and whisker plot, minimum up to the maximum value. So that's it, guys. We were going to have something of that nature. Then on 1.4, they are saying the tourism sector claims, all right, the tourism sector claims that 20% of the resort centers which is 20% of these 20 resort centers. They're the ones who are being talked about there. 20% of them recorded temperatures too hot for tourist activities. All right. Then determine the minimum recorded temperature that satisfies the above claim. The minimum recorded temperature. They are saying these temperatures, they are too hot. So which one can be the required from the 20% that we are given? So what you just need is to find the 20% of the tourists which are there, the number of tourist resort that we have, the centers. Those are the centers which were being interviewed there. And they're the one which are giving a report. So 20% of them were given, that is 20%. So that's 20 over 100 of that, which is 20. So 20% of these 20 tourist resort centers was going to give us 4. So this is what you do. If they were complaining about the minimum, to say the temperatures are too low, you were going to start from the lower temperature going up. You count up to the 4th value. You're going to count 1, 2, 3, 4, meaning to say this is the one that is going to satisfy our condition. Let's say they were complaining about the temperatures being low. But in this case, they are not complaining about the temperatures being low. They are saying they are too hot for tourist activities. So we are supposed to count from the one which is the maximum, the hottest one, going down to the one which is supposed to satisfy the 4th position from the maximum. So this is the maximum. That's 1, 2, 3, 4, going down, because we need from the hottest. They're complaining about being hot. So we take from the hottest one going down. So meaning to say at 37, this is the value that we are going to have. This is the minimum required temperature, which can satisfy those resort condition, those tourism condition. That is at what? At 37. So that therefore 37 degrees Celsius satisfies these resort condition, satisfies the above claim. Okay, the given claim. That was our condition there. They are complaining of being too hot. So we start from the maximum, counting those numbers going down. 4 digits. 1, 2, 3, 4. The 4th one. If they were complaining about being low, we're going to start from the lower, going 1, 2, 3, 4. We take that one at the 4th one. So we just have to be careful in our presentation. On question number 2, that is of grouped information. We can see that this time we're given 80 to 95, 95. This is grouped information. So a supermarket sells light bulbs. The store keeps a record of the wattage of the light bulbs that they sold in the month of October 2023. It is giving records, keeping those records. The monthly sales are summarized in the table below. These are sales which were being taken in terms of the wattage. Those ones with this wattage, 3 were being sold, sales. This one, 17, this one, that is the sales being made. So the question is, how many light bulbs were sold in the month of October? We just need from the total frequency, because we saw these ones, the 3 were sold, 17, 31. So the total of these numbers, the total of the frequency, is the number that is representing the number of what? Bulbs which were being sold in the month of October. So you're just going to add 3 plus 17 plus 31 plus 16 plus a 10. You add these, all the numbers that we are given there. That was going to give us 77 light bulbs. So 77 light bulbs were being sold in this month of October. On 2.2, write down the model class of the data above. The model class is the one with the highest frequency. The class that has the highest frequency. which class is having the highest frequency. The highest frequency, the biggest number is 31 under the frequency. But which class is having that? The class, this one. This is the class, the interval. These are classes. So you're talking about the class with highest frequency. So that's 110 to 125. So x is greater than or equal to 110, but less than 125. We write as it is given there. That is the class. That is the class where the model class, you're talking of the model class there. All right. Then we move on to another question, which is determine the interval. Again, the class, the interval is the class. We're talking about the class there, in which the median lies. Where is the median going to lie? This time we are dealing with grouped information. It is just like we are dealing, remember, grouped information is also used on a cumulative frequency curve. Remember when I explained the cumulative frequency curve? If you're dealing with the grouped information, the median, it is just the position this time. It is just halfway up. The median position. It is just halfway up, half of n. There's no need for us to use half of n plus 1. Yes, you can do that, half of n plus 1. It does not even affect. You're still going to have the same answers. But it is just halfway up for the grouped information, meaning to say it is half of the total frequency that we are given. N representing the total frequency, which is 77. This is the position that we are supposed to be talking about. So that's at 38. That's at 38,5. That is the position where the median is going to lie. Where are we going to have this? If we count up to 38,5 in terms of the frequency, we have to count now. You have to count these numbers that we are given up to a condition where we get 38,5. So the first one is 3. We add this 17 that we are seeing. That is going to give us what? That is going to give us 20. We are not yet at 38,5. We are below that value. We add again the next value, which is 31. So 20 plus 31 is going to give us what? 51. So as we can see, we are obtaining 51, meaning to say this 38,5 is found in this inside of the 51. When we were counting, it was going to be found inside. It is less than 51. So it is inside this. As we are counting numbers from 20 there, you are counting 21, 22, 20, 38,5 was going to be found in between as you are counting. So in these numbers, as you can see, in these numbers, where is it located? That is the class that we are talking about, the interval. Where is it located? Where are we having that value of 38,5? It is going to be found in this interval of what? 110 that we are given there, where x is greater than or equal to 110, but less than 125. That is where our median was going to be found. We write that interval as it is given there. On 2.4, express the number of light bulbs with the most popular wattage. With the most popular wattage as a percentage of the October sales. So meaning to say the most one is the one that we just see having what? The highest frequency. Where are we having the highest frequency? That is where we just take the most popular, which is what? 31. But they need what? Percentage of the total sales. So what is going to be the percentage now? Remember the total sales, how many were being sold? 77. This is the total. So remember percentage, 37 over 77 times what? 100% as a percentage. So that was going to give us a percentage, 40,26 to 2 decimal places. Remember your instruction to 2 decimal places. 2.5, estimate the mean wattage of the light bulbs that were sold. The mean. This time we are dealing with grouped information. Under ungrouped information, we're just taking our values to say, this is the mean. This is ungrouped information where the mean, we just count the sum. We just add the sum of x over n. But this time, we are going to notice that the mean is given. Okay, this is 2.5. So the mean is going to be taken from the sum of the product of the frequency to the class midpoints over the sum of the frequency. So we need the sum. This x here is now the mid values, the midpoints. These are class centers, which is also referred as the class centers. So we need the product, the sum of this product, frequency time. We have to multiply frequency times the class center of this one. So meaning to say, in each interval that we are given, in each and every interval that we have, you are supposed to have what? The class midpoint or the class center. What is the class midpoint of this class from 80 to 85? What is the midpoint there? So we're going to add each 80 plus 95, 80 to 95, 80 plus 95. That is finding now the midpoint. You divide by 2. This is how we are going to have each and every class. So it was going to be 87,5. So meaning to say here, we have got 87,5. You do the same thing. 95 to 110, you add 95 plus 110 divide by 2. So it was going to give us 102,5. So this is how you're going to have it up to the last digit. You do the same thing, 110 to 125. You add the 2, divide by 2. It was going to give you 117,5. You do the same thing on this other one. It was going to give you 132,5. You do the same thing on the last one. It was going to give you 147,5. So these are the class midpoints, our class centers. So meaning to say, in terms of the mean that we are going to have, you are going to multiply these you add them. You multiply these, you add. You multiply these two. You add to this other product and so on. So it was going to be like this, 87,5 multiplied by 3 plus, you add the next one, 102,5, you multiply to 17. You take the next one. This is, you can just do this one on your calculator to just take the total there. 117,5, you multiply to 31 plus 132,5, you multiply to 6 and so on. 132,5, you multiply to 16, you do the same thing, 147,5 and the 10. That was 147,5 and the 10 that we are seeing there. Everything divided to the total frequency. Remember, the total frequency is the number of these all light bulbs, the total frequency that we added before. Remember, we got a 77. So that was going to be the calculation there. So meaning to say, on top, multiply, adding these, we are going to obtain 9,242,5, everything over 77. Then to 2 decimal places, it was going to give us 120,03 as our mean. So you need the mid values, the midpoints, in order for you to obtain what? The mean or the average. Then on 2.6, they are saying the manager of the store decided to display the data collected on a pie chart. He wants to represent it on a pie chart. Calculate the size of the largest angle of the pie chart. We are not representing, we just need to calculate the largest angle. So how are we going to determine the largest angle from this information that we are given? So definitely, in order for you to obtain the largest angle that you'll be given, you are going to need the biggest value in terms of the frequency, the most frequent one, which is 31. Remember, the angle, which is theta, is simply taken from the frequency over the total frequency times what? 360 degrees. That is to calculate the angle. So the angle that we need, which is the largest, we are going to need the largest value in terms of the frequency, which is 31. So that is 31 over what? The total frequency. What was the total frequency? Remember, when we added this, we got 77. Then whatever that you're going to obtain, we multiply to 360 degrees for the complete rotation, a complete revolution. That is in terms of the angles. We are dealing with angles. So we must use what? 360 degrees. So that was going to give us the angle, which is 144.94 degrees. This is the largest angle that we can ever have from this information. If a pie chart was to be drawn, the question is not for you to draw the pie chart. No. On question number 3, we are given in the diagram below, P is given. We are also given the point A, the point N, M are the vertices of a parallelogram. All right, so we are given this is a parallelogram. This is P to A to R to M like this. That's a parallelogram. Then we are given PMT is a straight line where M is the midpoint of PT. So this M here is representing what? The midpoint of PT. Then we are given the point T is such that PT is perpendicular to RT. So we can even see from our presentation, this is line PT, this is line RT. They are shown that it is perpendicular at what? 90 degrees. All right, so this is what we're given. The first question on 3.1, it was to determine 3.11, the length of PT. Leave your answer in said form. Leave your answer under the square root, the length of PT. So according to the diagram that we are given, we can see this is our P and that's our T from the line PT. So we can determine the length. Remember, the length of a line is taken from the distance formula, x2 minus x1 squared plus y2 minus y1 squared. So depending with the way that you have presented your values, you can say this is your x1, this is your y1, this is your x2, this is your y2. So meaning to say the length of PT was going to be the square root of x2, that is 10, minus x1, which is 8, which is 2 there. So that's 10 minus 2 squared. You do the same thing on the y values, y2 minus y1. So that's minus 3 minus 9, minus 3 minus 9 squared. Or you can even use the other way, x1 minus x2. You can use y1 minus y2. You can even use it that way. Still, you're going to have the same thing. So this is the length of PT. So that is 10 minus 2, which is 8. So you've got 8 squared plus minus 3 minus 9. That was going to give us minus 12 squared, which is, if we square these two, 8 squared was going to be 64. Minus 12 squared was going to be 144. You add, this was going to give us the square root of 208. Remember, they said in said form, leave your answer under the square root. So this is the length of PT, which is the square root of 208 units. You can simplify this on your calculator still. You can just simplify it on your calculator. You're going to obtain 4 square root of 13. It is still fine as it is. That is said form, as long you are not writing it as a decimal, as long you're writing under the square root. So you can also write as 4 square root of 13. It is still one and the same thing. So that is it, guys. We have got the length of PT, the whole part of PT. We have it. Let's consider another question. So there we obtain the square root of 208 or 4 square root of 3. 4 square root of 13, you can write as 4 square root of 13 if you want. 3.12, the gradient of PT, still on the line PT that we are given. This time we need its gradient. So remember, the gradient of a line, you simply need the change in y over the change in x. y2 minus y1 over x2 minus x1. That is y2, which is, according to these points, minus 3 minus 9. So that's minus 3 minus 9 over x2 minus x1. That is 10 minus 2. That is what you're going to obtain in that case. And that was going to give us minus 3 over 2 direct on your calculator. Then on this other question, 3.13, the gradient of the line AR. If we look closely, we'll see that there is nothing given on AR. This point is not complete. We are not having the point A, and there's no way that we can have these points now. So what can we do? We are told this is a parallelogram. So these two lines are parallel. AR is parallel to PM. If AR is parallel to PM, it means AR is also parallel to PT, the whole of PT, because the straight line. Remember, if two lines are parallel, they have what? Same gradient. So the gradient of the line PT that we calculated here is going to be the same as the gradient of the line that we need of AR there, because these two lines are what? Are parallel. So the gradient of line AR, the gradient of this line AR that we need is equal to the gradient of PT, which is minus 3 over 2. We are talking of what? Parallel lines. If two lines are parallel, they've got same gradient. If they are perpendicular, the product of the gradient is minus 1, but these ones, they are not perpendicular, they are parallel. 3.14, the coordinates of M, where we are told that M represents the midpoint. We have that M is the midpoint as we are being told before. So we can determine this M, that is 3.14. Remember the midpoint, we just need to add X values together, X1 plus X2 over 2. You add the Y values together, Y1 plus Y2 over 2. So that's it, guys. We've got the point M. So that is X1, which is 2, and our X2, which is 10. So that's 2 plus 10 over 2. The Y values, 9 and minus 3. So that's 9 plus minus 3 over 2. So that was going to give us the value, or the point M, 12 over 2, which is 6. This one was going to be 6 over 2, which is 3. So we have the coordinate of M, the midpoint, as we are being told before that this is a midpoint. So that was going to give us 6 what? 6, 3. All right. So as you can see, guys, if you have a revision proper, these questions, they're just direct and straightforward. 3.2, the equation of PM in the form y is equal to mx plus c. This is the gradient intercept form, the equation of PM. How can we determine the equation of PM? Are we going to start to find the gradient there? Because this is where we have our PM. And there's nothing that we have calculated about PM. We just calculated the point M. But are we going to start? That is the question. Are we going to start? If we check, the line PM is the same line as the line PT. It is the straight line. This is a straight line, remember. So meaning to say the gradient, as we consider PM, this is collinear. P, M, and T. That is the what? Collinear. Remember the condition of being collinear, same gradient. So it means between point P and M, between these 2 points, P and M, the gradient that we have is the same as the gradient between M and T. It is the same gradient between M and T. It is the same gradient as this one, the whole of the line PT. Remember, we talked about this being collinear. So using the collinear concept, they have the same gradient. So we have the gradient of PM because we calculated the gradient of PT. It was what? Minus 3 over 2. So the gradient is there. We just need the equation. Remember, they said in the form of y is equal to mx plus c, where m is the gradient and our gradient is there, minus 3 over 2x plus c. So we need to find the c from any point as long it lies on PM. P is there, M is there, we can take any point. So I'm going to use the point P where we are given X and Y there. Y is equal to 9. So 9 in place of Y. So we're going to substitute 9 is equal to minus 3 over 2 times X. And X on this point is what? is 2. So you substitute the point as it is x and y. You can substitute m, 6, and 3 in place of x, and in place of y, you can substitute. You're still going to obtain the same value of c. All right, so you can solve for c here. 2 and 2 was going to cancel. We've got a minus 3. We take the minus 3 to the other side. So it was going to be 9 plus 3, which is 12. So that's 12 is equal to c. So if c is equal to 12, therefore our equation is going to be y is equal to minus 3 over 2x plus c, our c, which is what? Which is 12. That's a plus 12 that you're going to have there. So this is the condition that we were going to have. All right, then on another question, right, let's check the other part. They are saying in this case, show that n is equal to a minus 5. So on the question, it was n is equal to 5. That was wrong presentation, and even the memo there, it was a wrong presentation. Let's check where n is so that we can see this part that I'm talking about. If you check properly on our graph here, all right, it's only that I had this too much here. If we check properly on our graph, like I was saying, the original question was saying, show that n is equal to a positive 5, which I'm saying that was a wrong question being asked there. And also the calculation on the memo there was actually wrong. N, if we consider this is the y-axis, this is the y-axis. As you calculate or as you count the values of x compared from this y-axis going to the positive, these values are supposed to be positive. 1, 2, that's why you see the x value there, it's positive 2. The x value here, it's positive what? Positive 10. The x values this side, they are positive. If we look into this other side, as we are going this side, the x values this side, they are negative. Negative 1, negative 2, negative 3, negative. They are negative values. So n is representing the x value. It's an x, the value of x here. And x at this point cannot be positive on this side of the Cartesian plane. On this side, x cannot be positive. X is what? Negative there. So please, you are supposed to correct that. And even the calculation, like I said, they just do a wrong calculation. You just know they just want to make things work where it is not supposed to be like that. All right. So as we are revising, also take note of your memo. If you have a challenge where you are not understanding the calculations which are being done on the memo, the comment section is there. Talk about it so that we look into that question, because it's not always where you have correct presentation or correct calculations on your memo. It's not always like that. So you must be very, very careful as a student also as you are revising. All right, no problem. So how can we find this n, which is representing the x value, which is on the negative side from the origin? This is on the negative side, and it's supposed to be what? A negative value that we have there. All right, so that's 3.3. We are supposed to show that n is minus 5. In this case, we can simply use this consideration that because we are told that PT and NR and this RT, PT and RT, they are perpendicular. Remember that. PT is perpendicular to what? To RT. If they are perpendicular, then what is the consideration that we have to use between perpendicular lines? It is on their gradients. The gradient of the line PT, when you multiply it to the gradient of the line RT, we must obtain a negative value. So in this case, the gradient of PT is already there. Remember, we calculated this. But that gradient of RT, we do not have. So we are going to calculate the gradient of RT in terms of what? In terms of n, because we have that RT here. So RT, we can just call this x1, y1, and this will be our x2, y2. So meaning to say we need the gradient, the expression of gradient RT, the algebraic expression. Remember, change in y over the change in x, guys. That formula is still going to work. Y1 minus y2 minus y1 over x2 minus x1. So y2, I'm just going to take minus 3. So it'll be minus 3 minus y1, which is a negative 13. So that's a negative 13 over x2, our x2, which is 10, minus x1, which is n. So this is in terms of what? In terms of n, as I said before. Minus, minus, that's a plus. So that's minus 3 plus 13, which is 10 over what? Over 10 minus n. So you are going to have this as the gradient of the line RT. Or you could have used it in another way. We could have used this in terms of y1 minus y2. So it was going to be minus 13 minus 3 like this over x1 minus x2. So it was going to be n minus 10. So negative 13 plus 3, it was going to give us minus 10 over n minus 10. This part, if you use it, or if you use this one, you are still going to obtain the same answers there. You are still going to obtain the same answers. Okay, I'm just going to do it so that we see that our n there was going to be a negative 5. All right, so we're going to substitute. Let's start with this one that we calculated first. Remember, PT, we have it minus 3 over 2 times the gradient of RT. The gradient of RT is the one that we just calculated. We use 10 over 10 minus n is equal to minus 1. So what are we going to have in this case? We can even simplify this, guys, as we can see that there is a product, and these two can even cancel the product. 2 into 2, that's 1, into 10, that's a 5. So you multiply minus 3 times 5, which is minus 15 over 10 minus n is equal to minus 1. So minus 1 is same as minus 1 over 1. So it allows us to perform cross multiplication in this case, where we are going to have minus 15 times 1, which is minus 15, is equal to. So take note on your cross multiplication. It's minus 1 times 10, which is minus 10. Minus 1 times minus n, which is a positive n. Take note, the minus 1 multiplies, it's like this, minus 1 into 10 minus n. It multiplies everything. You must be careful on that one. All right. So taking the negative 10 to the other side, it was going to be a positive 10. That's negative 15 plus a 10, which is equal to n. Minus 15 plus 10, that's minus 5, which is equal to n. So as you can see, truly, our n was going to be a negative 5. All right. So guys, it's not always that you just take everything that you see on your memo, you just take it as it is, and then you say it's correct. No. You're at a stage, at a level that you as an individual are supposed to see, no, this is a wrong calculation. And you're supposed to raise your hand and say, this is wrong. You're at that stage, guys. Where something that is wrong, say this, no, this is a wrong calculation that we are seeing there. Even on our calculation, you see a certain mistake. You're supposed to talk about that. The comment sections, they know. What about this calculation? What about if I do this, so that we explain in that manner and see? Because mathematics, the calculation, no matter the way that you do, you're supposed to reach the same answer if that calculation is correct. So even if we used this expression, remember, we can also have this as our gradient for line RT. So we're going to take our PT, which is minus 3 over 2 times, we use minus 10 over what? Over n minus 10. This is equal to negative 1. Let's see what we're going to have. We're going to have the same answer there. Also, just like the previous case, you can also reduce 2 into 2. That's 1 into negative 10. That's a negative 5. So you can even cancel here. Negative times negative, that's a positive. So this one cancels negative, negative. That's a positive. So it is going to be 3 times 5, which is 15 over n minus 10, which is equal to minus 1. Minus 1 is same as over 1 as a fraction. So cross multiplication is now necessary because we've got just two fractions, one on the left and another one on the right. 1 times 15, that's 15, is equal to negative 1 multiplies everything. So it's negative 1 times n, which is negative n. Negative 1 times negative 10. This is negative 10. It was going to give us a positive 10. So you can take the constants, the 10 to the other side, it was going to be a negative there. So 15 minus 10, which was going to be a 5. 15 minus 10, that was going to be 5, is equal to minus n. This is minus n. So to find n, divide by -1 by -1. So our positive n is 5 divided by -1, which is what? Minus 5. So truly, n was going to be a -5, all right? Not a positive 5. No. That one was actually a wrong calculation. Then calculate the area of triangle RMT. The area of this triangle RMT. Remember, we just calculated now the value of n. So from that mem again, because they were using the wrong value of n, their area also became wrong because they were using a wrong value of n. Remember, our n is a negative, like I explained before. It cannot be a positive on this side. So this point, we calculated this, we know that it's -5. So that's -5, -13. That's our point R there. It's going to help us because we need area. So the area, one, we are dealing with a triangle. What type of a triangle is it? If we check the triangle that we are talking about, which is RMT, this triangle here, it is a right-angled triangle. You can see that it is right-angled at what? At T here. Remember, I told that this is perpendicular. So you can simply use the area of a right-angled triangle, which is half of the base times what? Perpendicular height. So area is half of the base times the perpendicular height. So we need the length of MT. Remember, this is triangle RMT. So we need the length of MT. We also need the length of RT, the ones that are perpendicular, the lines which are perpendicular. MT is perpendicular to RT. Are we having the length of MT? Remember, I told that M is the midpoint, and before we calculated the whole length of PT, if you take note, when you calculated that length of, it's only that we removed, but we calculated the length of PT here. When I said it gave us 208, square root of 208, which is equal to 4 square root of 13. Remember, it was 4 square root of 13. So we simply need half of that because PT, take note where PT is the whole of this line and M is the midpoint. So from M to T, it is half of that, this MT. It is half of what? It is half of PT. So if it is half of PT, we calculated the length of PT before. All right. It gave us square root of 208 or 4 square root of 13. So I'm going to use 4 square root of 13 in simplest form. Half of 4, this is 2. So you're going to have 2 square root of 13. This is the length of what? MT. Or you can calculate it using the both. You have the length, you have M and T. You have M, you also have T. You can calculate if you do not understand this, calculate the way that you are used to your distance formula. Your distance formula X, this minus, you subtract 10 minus 6 from M to T. So it is going to be 10 minus 6 squared plus the Y values minus 3 versus what? Versus 3. So that's minus 3 squared. You use your distance formula, still you're going to obtain 2 square root of 13 as the length of MT. All right. So we also calculate the length of RT. So as we can see, RT, the length can be calculated. We have all the values. So using the X values, so you're going to subtract the X values. This one minus this one, that is minus 5 minus 10, or the other way that you understand, minus 5 minus 10 squared. Remember your formula, guys, plus the Y values, minus 13 and a minus 3. So that's minus 13 minus 3. So remember a minus and a minus, that will give you a positive. So just use your calculator, guys, at once. This was going to give you 5 square root of 13 on your calculator. You have the length of RT there. 5 square root of 13. So with these two lengths that we just calculated, with these two, the length of M to T and the length of RT, the area can be calculated because that is what makes the base and the perpendicular height. Remember, base and perpendicular, the one that are at what? 90 degrees. So that was going to be half of the base, which is, I'm going to take 2 square root of 3. You can take even this one, 2 square root of 13. You can even use this one as your base, anything. Then you use this one as your height. It's up to you, the product. There we just need the product. So that's 5 square root of 13. So the product of these guys was going to give us the area. So you can even use your calculator, or you can just multiply half of 2. That's 1. Square root of 13 times square root of 13 is going to give us 13. Then 5 times 13 was going to give us what? 65. Or you can just use your calculator at once. This is area measured in what? In a square units or unit squared. So that is how the questions can be given as. Questions can be given in this nature. You just have to be careful. On question number 4, considering our trigonometry, we are given question number 4 on 4.1. Use a calculator. They're asking you to use your calculator there to find the values of the following correct to 2 decimal places. 4.11, to simplify 4 sine 65 degrees. Just use your calculator there. They told you to use a calculator. And to 2 decimal places. So you just need our calculator and make sure that your calculator is having this D there, degrees. So that's 4 sine of what? Sine of 65. So this is what you're going to have, 3,6 and so on. So you can even fix your calculator to 2 decimal places. Shift, go to the setup. You fix, which is number 6, press 6, then you press 2. So your answer is direct to 2 decimal places there, 3,63. So that's 3.63, just like that. You move on to another question. That is cos squared 32 minus 30. So whenever you're given a squared like this, you are going to have it this way. So this one is just on the presentation that you are going to have. So instead, we can just have this one as cos, that will be 32 degrees minus 10 degrees like this. So your calculator is going to show you like this, but you need to square it. So you must have another bracket like this so that this can be able to be squared and everything is over what? Over tan 22 degrees like this. So you can simply evaluate in this manner on your calculator as long your presentation is in this form. So in this case, we were going to have our calculator. So this is what you're going to have. So we are going to have a bracket first. That is the cos. So automatically, as you can see, your calculator is having a bracket. It is opening a bracket for you, which is 32 minus 10. You close that bracket, then also close it. The first one, remember there was a first bracket that you have to close it. You square it, then divide this by what? You're going to divide by tan 22. That is what you're going to have. So remember, we have fixed our calculator to 2 decimal places. So we are going to obtain our answer to 2 decimal places, which is going to be 2,1, 2,13. So that is the use of a calculator. They can actually ask questions of that nature. Use your calculator to simplify that. On 4.2, calculate the value of theta or determine theta from this interval that you are given from 0 to 90 degrees. When we are given that this is 3/2, so we have to consider this our trigonometric equation that we are given. So this is 3, not 3/2, but that's 3. So we are given as 4.2, which is 3 sine of theta over 2. So you've got theta over 2 minus 20 degrees is equal to 0,85. So this is what we have. So in a normal presentation, we are supposed to be given, let's just say it is sine of theta being equal to 0,5. How are you going to obtain the angle? Theta is representing the angle, the part where sine is. So you're going to say theta is equal to the arc sine of what? Of 0,5. So in the same situation that we are supposed to have the part where the sine is. And this part of sine that we are seeing is the whole of this. This is the part where the sine is affecting. So anything that is not having that sign can be removed. What is it that we have? The 3 that is multiplying this 3. We can reduce this, just divide by 3. We divide by 3. All right, so that was going to give us the sine of theta over 2 minus 20 degrees, which is equal to, you can have it as a decimal or you can just leave it like that, 0.85 over 3. You can leave it like that, as it is, as a fraction like that with this decimal. So remember what I was talking about. You need the arc sine. So this is the angle that we are seeing in our presentation now. We are talking of what? This angle. This whole part that we are seeing here is representing our angle. This is our angle that we have. So to obtain the angle, we must remove the sine that we have on this side. Take it to the other side. So that is going to be theta over 2 minus 20 degrees is equal to the arc sine. To remove this sine, it is going to be written this other side as arc sine. That is arc sine of 0.85 over 3 like this. So this is the angle equated to the angle that we are going to have. So whatever that you are going to have from arc sine is representing the angle. So that's theta over 2 minus 20 degrees is equal to. So like I said, there is no need for even us having this as a decimal. We can just use our calculator straightforward. Arc sine, that is shift sine like this. That is arc sine, shift sine 0.85 over what? Over 3 like this. All right. So that was going to give us 16.46 as a decimal to 2 decimal places. That's 16.46 degrees. So you can even use your calculator direct. Yes, you can divide this, you have your decimal, whatever that you're going to have, 0, this, you simply use arc sine of that decimal. Still, you're going to have the same answers. So as you can see, since they need us in between 0 and 90, there's no need for us to find any other angle. We're just going to use this. All right, so in between that interval, we are going to have our answers. So this is now a normal equation because these are degrees. And you are going to have your theta also in what? In degrees. So you can transpose the 20 to the other side. It was a minus. So it is going to be a positive 20 on this other side. So that means theta over 2 is equal to 16.46 plus 20, which is going to give us 36.46 degrees. So to obtain theta, this is the same as over 1. So you can simply cross multiply the 2. The 1 multiplies this side, the 2 multiplies this side. So that's theta is 2 times this. The product is going to give us 72.92 degrees. That is the theta, which is going to satisfy the conditions that we are given there. So as you can see, guys, these typical exam questions, they can be in this manner. We just have to work with more questions. If you check other questions, they just ask similar to this one. On 4.3, without the use of a calculator, determine the value of. Without, now we are not supposed to use a calculator, meaning to say we are supposed to be working with our special angles. Remember your special angles from the 45 degrees. If you are given this is 45 degrees, this is 45 degrees, then this is 1, this is 1, this is square root of 2. We work with the 30 degrees. So guys, I say there's nothing special about these angles that we are actually calling them special angles, because whatever that the special angle is supposed to do, even your calculator is going to give you the same thing. So do not be worried on this type of a question, guys. You can use your calculator to simplify. They are just saying, don't use a calculator to simplify everything at this stage. But to simplify like cos 40, you can even use a calculator there. You can even use a calculator there. So the cos of 45, instead of us going to this part to say cos is adjacent over the hypotenuse 1 over the square root of 2, which is same as square root of 2 over 2. We can just use our calculator to simplify this. It is going to give us the same answer. So cos 45, that is the square root of 2 over 2. Over what? The sine of 45, you're going to see that you're going to obtain also square root of 2 over 2. This is the sine of what? Of 45. But they're saying we're supposed to add. What are we supposed to add? 4 cosec 90 degrees. 4 cosec 90 degrees. What does cosec represent? Cosec represent what? Cosec 90 degrees is the same as 1 over sine. Remember, cosec is 1 over sine. 1 over sine 90 degrees. And sine 90 degrees, you can use your calculator there. That is a 1. 1 divided by 1 is 1. So the cosec of 90 degrees is equivalent to what? To 1. So that's 5 times 1. Multiplied to what? 3 tan squared. So like I said, whenever there's a squared, this means it is like this tan of 30 degrees. Then we square it. So you find tan 30, then you square it. So you're going to see that the tan of 30 degrees, it was going to give you, if you simplify, this was going to be square root of 3 over 3. This is the tan of 30. But it must be squared. So this is 3 into the square root of 3 over 3 squared. As long as you show these stages, guys, they're not going to even be sure that you used a calculator or not, because the special angles, they still give you these M answers. So in that case, just use your calculator. Just use your calculator there. Then you indicate now stage by stage. This one and this one can cancel. That's a 1 plus the body mass. Remember your body mass, there's a bracket here. 5 times 1, which is 5. Then there's a multiplication here. This one, the square root of 3 over 2 squared. You can even use your calculator there. That is going to give you 1 over 3. So you're multiplying 3 times 1 over 3. Okay, which is going to give us what? A 1. This is same 3, and this going to cancel. That's a 1. So meaning to say we are going to have 1 plus 5. 5 times 1 is 5. And 1 plus 5 is going to give us what? A 6. So this is what you're going to have from this one. Simplifying this without a calculator, you can simplify this stage by stage. But like I said, do not use the calculator direct on everything. You can use the calculator stage by stage. This one, you use the calculator another stage. Guys, no one is going to even understand that you have used a calculator there. On question number 5, you were given that if 5 cos of beta, 5 cos of beta minus 3, is equal to minus 3. And our beta, which is the angle, is taken between 180 to 360 degrees. With the use of a diagram, calculate the value of the following. Do not calculate the value of beta. Do not calculate beta, but use a diagram. All right. So this is it. We just need a ratio for cos. So the ratio is supposed to be a fraction. So divide by what? By 5. Divide by 5. Both sides like this. So it means the cos of beta is equal to minus 3 over 5. Remember, cos is a ratio which we are taking, remember, from that SOHCAHTOA concept. But in this case, this cos which you're saying is adjacent over the hypotenuse, it is having a negative value. That is where this interval is playing a role to say, where is it that cos is a negative from our cast concept? Where is it that cos is found as a negative? All right, let's start with where cos is a positive. Cos is positive where? All and in this quadrant of C, cos there is positive. It is negative in this quadrant. Cos there is negative. And in this quadrant where we do not have that cos, where we do not have C, cos there is what? Negative. So the best answer that we're going to have where this cos is negative was supposed to be this region or this region. But take note, they gave us an interval between 180 and 360. Remember, these are your angles: 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360 degrees. So they are saying your answer is going to be taken, your diagram must be in between 180 to 360. So between 180 and 360, where are we going to have our answer? The answer is going to remain in the third quadrant where cos is negative. Between 180 to 360, you must use that interval. It is not just there for nothing. No. That interval, it is playing a role between 180 to 360. Where is cos a negative? Cos is negative in this quadrant. So that was going to be the best answer for us to have. So we're going to have our quadrant in that third quadrant. That is where we're going to have our answer in this third quadrant. So we're going to have our triangle. Remember, our triangle, guys, does not change. Our triangle is going to be a right-angled triangle like this. All right. So remember, if it was this quadrant, it was going to be like this. If it was in the first quadrant, it was going to be like this. If it was in the second quadrant, it was your triangle. They do not change the way that you present them. So let's present, guys. This is our beta. And they are saying that is -3 adjacent. This is our adjacent side. So that's -3. And the hypotenuse, this is our hypotenuse, which is 5. So that is the triangle that we're going to have. So with this triangle, we can find the value of sine beta. We can determine that sine beta because we do understand that the sine of beta is equivalent to what from those ratios, opposite over hypotenuse. So we need the opposite according to this angle. We need this opposite where we do not have. So let's calculate the opposite first. All right. Remember that hypotenuse squared is equal to x squared plus y squared. Our hypotenuse is what? Is 5. So 5 squared is equal to the x value, which is -3. So that's -3 squared plus the y value, which is the one that we need. Remember, this is our x and this is our y. So we need to calculate the y value, and it's a negative according to this side. Y there is a negative. So we're going to obtain 5 squared, that's 25, is equal to -3 squared, which is 9 plus y squared. Take the 9 to the other side, it was going to be a negative 25 minus 9, which is 16. So 16 is equal to y squared. How do you remove the square? You introduce the square root both sides, and knowing that the square root of any number is a plus or minus, so y is equal to plus or minus a 4. Plus or minus. So according to this region, we are talking of what? A negative value. If it was on top like this, it was going to be a positive 4. But here it is negative. So that's the purpose of using the Pythagoras theorem to find the third side of the triangle, and also to locate whether it is a positive or a negative from the quadrant, from the diagram now. So let's find our sine of beta. So sine of beta is going to be what? What is the opposite? Opposite is -4 over the hypotenuse, which is what? Which is 5. So that was going to give us -4 over 5. Just like that. Then on the other question, they want you to find the tan squared beta minus cot squared beta. All right, remember, that's it. All right, so let's save it here, 5.2. So tan squared beta minus cot squared beta. Remember, tan, we can have this value for tan. Tan is equal to what? Opposite over adjacent from our SOHCAHTOA. From our SOHCAHTOA, opposite over adjacent. But for cot, we can use the opposite now. Remember, cot, it's 1 over tan. So cot, if it is 1 over tan, is the opposite of this. So it will be just adjacent over what? Adjacent over the opposite. Adjacent over the opposite of that one. Remember, cot theta, it's 1 over tan of theta. So if you want cot theta, it will be adjacent, the opposite of that. So meaning to say, tan, we can find it opposite over adjacent, we just square. Then for cot, the opposite now for cot, so it will be adjacent over the opposite squared. That's it. So what is the opposite according to this? Our opposite is -4 over the adjacent, which is -3. Remember, according to beta, this is your opposite, this is your adjacent, this is your hypotenuse, which is the part of 5. So that's -3. We square it. Minus adjacent, our adjacent, -3 over what? The opposite, which is -4. We square that. So that is what they wanted you to just simplify, just like that. So the first one, if you square this on your calculator, it was going to be 16 over 9 minus 9 over 16. Then you can use your calculator again. It was going to give you 175 over 144. So that is it. Questions can be of that nature. Questions can be of that nature where they want you to play around the diagram that you are given, know your ratios, know your trigonometry, go through your introductions. Go through the introductions. That's why we are bringing you the introductions, so that you analyze what is it that is supposed to be done under a certain topic. It is not just about the the question papers, but also the introduction of that topic. If you know the introduction, it's going to be easier for you to attempt any question paper, any exam question that you'll be. So looking into the other question, which is question number 6, we were given our graphs of f of x, hx, and also the graph of gx, which is the tan of x. From 0 to 360 are drawn below. So they want you to determine on 6.1 the values of A, P, and Q. So we have to follow up and see where these values are found. Where are we having A? If we are to take a closer look, A is on the graph of a sine. This is a sine x plus Q. This is the graph of sine. If we check properly, this is our F, this one. It is like this. All right, this is what we are having on the graph of a sine. So if we take a closer look, we'll see that this is the opposite way of what we are supposed to expect our graph of a sine to be. Remember, the graph of a sine is supposed to be something like this. To 90 degrees, it goes to 180. It is supposed to be having at least a shape like this one, where A representing the maximum value there. If it is like this one, it will be having a positive value. So from this function that we are having, it is the opposite way, meaning to say it is going to be a negative value that we are going to actually have there. It is going to be a negative value. After that, knowing that it's supposed to be a negative value, one thing that we are supposed to consider is that the normal maximum value of a graph of a sine, it is supposed to be at 1 like this. It's supposed to be at 90, at 180, at 2, at this 180, then 270 versus minus, like it's supposed to be maximum at 1. It's supposed to be at 1. So what happened on this graph that we are having, that we are seeing our graph, as we can see, this one is going to -1. There it is going up to +3. So if we take this, it means the difference that we had, it was supposed to be 1, but because of being negative, remember our graph was supposed to be like this, but this one is in another format like this one. So it will be a -1 instead. All right. So actually, there are so many ways that you can have that maximum values depending with your understanding. So our A was going to be a -1. Then for P, we can also do the same thing on this graph of a cos, because this is a cos. Nothing has been added on H. Remember H, this is our H, this one H. So this is the graph of a cos. And this is the normal way that we are supposed to have our graph of cos. This is the normal way our graph of cos is supposed to be like that. So meaning to say the maximum value as it is going up is the one that we just need. It goes down to -2, but up it is going to up to 2. This is up to +2. So you just take that one as it is, as a positive. So your P there was going to be a +2. Then to find the Q, Q is affecting the graph of X. So remember we said A is -1. So it is just like Y is equal to minus sine of X. Remember A is -1, so it's -1 sine of X plus Q. So you can find the value of Q by substituting any corresponding point that is given on your graph, any corresponding point. If I'm talking about any corresponding point, I'm talking on this graph of F. Remember, this is the graph of F. You can just substitute any corresponding point like this one. 90 corresponds with what? With 1. If X is 90, Y is 1. So it is just that consideration that we are seeing there to say Y is 1 if our X is what? 90, 90 there, 90, 90. X is what? 90. So it will be minus sine of what? 90 degrees plus Q. So you can just, any point, you can move on. That is anything visible. 180 versus what? Versus 2. 270 versus what? Versus 3. 360 versus what? Versus 2. You can use any combination as long as it is a complete point. So use your calculator to simplify. Minus sine 90, it was going to give you -1. So 1 is equal to -1 plus q. You can find the value of q, take this to the other side. It was going to be a positive 1 plus 1, which is 2. So 2 is equal to q. So q was going to be a 2. So that's it, guys. That is how you're going to have this value of q. Just substitute. So meaning to say our f of x is equal to minus the sine of x minus the sine of x plus 2. Meaning we can substitute any value and test. Let's say at 0 degrees, if you substitute a 0 there, it will be minus sine 0 plus 2, which is 0 plus 2, which is at this 2. Let's take at 90 degrees. Let's just take this one at 90 degrees. If we substitute 90 degrees, it is going to be minus sine 90 degrees plus 2. Minus sine 90 is what? It's minus 1 plus 2. Minus 1 plus 2 is 1. As you can see, it is corresponding at 1. So this is the exact function. That is how it was supposed to be. If you substitute any value, if you substitute 180 here, you must get your answer as -2. That is how it is supposed to be. If you do not get that, then it means that function is wrong. You must get your answer as what? As +2. Sorry, this one, 180 is going up. 180 is going up. 270 is going up to 3. 360 is going up to 2. If you substitute these values and you do not get those answers, it means our graph is wrong. All right. The same thing on our hx. We said our hx is equal to p is 2. That's 2 cos of x. If you substitute any value, let's say at 0 there, you substitute 2 cos of 0. You're supposed to get a 2, which is exactly the value that we have there, which is a 2. If we substitute 45, we are supposed to get the value that is corresponding 90. It is supposed to be like that. That is how our graph is supposed to be like. All right. So that is our values, guys. On this case, we just have to be careful. Then determine for which values of x, we're talking of x there, is hx less than or equal to 0 from 0 to 360, where hx is less than 0. This is the graph of hx. Remember our h, the graph of a cos, this one. So we want it where it is less than a 0. So we compare the y values along the x-axis. Remember, in the x-axis, y is equal to 0. So going up, that means y is greater than what? Y is greater than 0. Going down, it means y is less than 0. So going down from the x-axis going down, that's where y is less than 0. Going down. At this point in the y-axis, that is exactly equal to 0. So you see that this is the region below the x-axis. This is the region that we want. So between which values? It is between 90 and 270 degrees. So it is between 90 and 270. So because they have an equal to there, we are going to use an equal to also on our answer. So x is greater than, we said 90 up to what? Up to 270 degrees. So it's supposed to be less than or equal to 270 degrees. So this is the interval that we are talking about, x being any real number that is in between there. Determine for which value or values of x will f of x be equal to hx. Where are we having these two being equal? F of x and what? And hx. Where are they equal? This is our f of x, remember? Our f of x is the graph of sine, this one. So where are they equal? They just need a point of intersection. So this is our hx. Sorry, our f of x, this one. That is our f of x, sorry. Let's just try have it proper like this. This is our f. And considering our h of x, this is the graph of a cos that we are given. The graph of a what? The graph of a cos. So they need the x values where these meet. Okay, so we can see that they meet at this point. That's a point of intersection. X is equal to what? X is equal to 0. They meet at this point. This one was supposed to be at around 45 there. This one, it was supposed to be at 45. And another one at what? At 360 degrees. They also meet there according to what we can see from our graph. That one, we're just going to approximate to 45. So that's at 0 degrees, at 45 degrees, and at 360 degrees. Remember, we're talking of the x values. So that is how it was supposed to be like from our graph there. All right. Then write down the range of f. So the range, these are the y values that we're talking about of f. F is limited from where to where? Remember, this is the graph of f, this one in red. Where is it limited in terms of the y values? As you can see, the minimum value is this one. This is where we have the minimum value, which corresponds to what? To 1 on the y values. The maximum value on the graph of f is this one. The maximum where it is turning there, the turning point, which corresponds with what? With 3. So our graph is limited between 1 and 3. It cannot exceed these values. It will be fluctuating between 1 and 3, 1 and 3, 1 to 3. So in between 1 and 3, that is our range. So y is supposed to be greater than or equal to 1, less than or equal to 3, where y is representing any real number that we can actually obtain in that interval of 1 to 3. That is how we can have our graph S. All right, on question number 7, we were given, this is part of our trigonometry again, we are given a triangle where we are given the diagram shows a spotlight at B. So there's a spotlight at point B, here at point B. So this is the indication of what? The spotlight, these dotted lines. So that is what? The spotlight, where it is going to view. So they are saying, which is mounted 12 meters directly above point C, directly above, meaning to say that's a vertical line. And they are given the spotlight swings 43.3 degrees from the vertical to illuminate another point D, the midpoint. So from this point, this is the swing 43.3 degrees. All right. Then to illuminate the point D, which is the midpoint of AC. So D is the midpoint. It is in between. It is the midpoint of what? Of AC. That's the indication that we are given there to say the distance from A to D is the same as the distance from D to C. So the first question was for you to calculate the length of DC. So if we are to take a closer look on our diagram, we'll see that using this triangle B to D to C back to be like using this right angle triangle, it is enough information for us to calculate the length of DC from D to C. This is a right angled triangle. Remember, guys, on a right angled triangle, you are given an angle there. Remember, there's an angle inside, 44.3. This is your B, this is your C, this is your D, this is 12 meters. We can find this side. We have this right angle triangle. According to the angle given, this side is what? Is the opposite. And the given side, BC, the one that we are given is representing what? The adjacent. Which ratio uses? Remember your trigonometrical ratios. This is a right angle triangle from our soccer tour. Which ratio uses opposite and adjacent at the same time? Opposite and adjacent is found on tan. So that means we're going to calculate the length of DC because we have a ratio there. The tan of the angle that we are given, the angle that is inside of the triangle, 44.3, is equal to the opposite over the adjacent. What is our opposite? That is DC, the line to be calculated. And what is our adjacent? That is our BC, the one that we are given as 12. So this is over 1. Remember, you can use this cross multiply. That's finding the length of DC. 1 times DC, that's DC is equal to 12 multiplies tan. So that's 12, the tan of 44.3 degrees. So this is you guys and your calculator. You can simplify this direct on your calculator. It was going to give you 11.71, which is in what? In meters. Remember, this other length is in meters. So that's the length of DC. So we are given the length of DC from this, that's 11.71. But remember, it is the same as AD because D is the midpoint. So also here, it's 11.71 meters. Then they want you to determine on 7.2, calculate through how many degrees, that is the angle that is to be calculated there, the spotlight must swing in order to illuminate point A. That is, calculate theta. So the question is specifying, that is, calculate theta from this information that they're asking you. They are simply saying, calculate the value of theta. If we are to take a closer look again into our diagram, where theta is found, it is in this triangle from A to B to D and back to C. This triangle that we are seeing here, where theta is found, it is a non-right angled triangle. And we do not have necessary information. We just have this angle with this side and this angle that we need to calculate. Those are the only two things that we are given. So it is not giving us all the information that we need to calculate that angle. So we cannot consider this triangle on its own. It is not having what we need. All right. But let's say we take the wall of this triangle from A to C to B, then from B to A, we take the wall of this triangle like this. It means we are calculating the wall of this angle inside of the triangle, which involves or which consists of the theta. The theta is inside of that angle. So let's just call it beta. All right, guys, we are used to this angle, so you can call it beta, or you can just leave this beta thing and just use it as ABC, the angle ABC. So using the wall of the right angled triangle, so that's 7.2. So using the right angled triangle ABC, using that, calculate from that, calculate angle ABC first. So we're going to calculate angle ABC, this angle. By calculating angle ABC, we can calculate theta because theta is inside of that ABC. So remember, you're taking the whole of this triangle. So what is that we have according to this angle that we want to calculate? What are we given? All right, so if we check properly, we are given BC, this side. This is where we have our 90 degrees. Remember, we are given BC, which is 12. So that is, we are given the adjacent. And we also have the wall of AC. We are using the wall of this line AC. So AC is equal to what? AC, the wall of this line is the one that you're going to use. So you're simply going to add. Remember, we said these two, they are equal. So you're just going to add 11,71 plus 11,71. You add those two, or 11,71 times 2. That is one and the same thing. So that was going to give us 23,42. So using that triangle, this 23,42 that we are given, what is it representing from this angle? What does it represent this side? It is the opposite. It is facing the angle that we want to calculate. That is opposite side. So we have opposite and adjacent. Which ratio uses opposite and adjacent at the same time? We are back to that tan. So it means tan of the angle that we need to calculate, the wall of this angle, not theta, but the wall of this angle, angle B. That's ABC. So the tan of angle ABC is equal to what? The opposite. What is our opposite? That's 23,42 over the adjacent, which is 12. So this is it. Just like what we saw, guys, to find an angle when given a trig here, it is tan, it is cos, whatever that you're given. To find this angle, it is going to be arc value of what you're given, arc tan. If it is sine, arc sine, arc cos. So they were dealing with a tan. So it follows that the angle ABC, the angle ABC, sorry for that, we need the angle ABC. It is going to be referred as the arctan. Remember, it was tan. To write it here, it is going to be written as arctan. That's 23,42 over 12. So on your calculator, guys, just use your calculator straightforward. You're going to obtain angle ABC, arctan, shift tan on your calculator. That was going to give you 62,87 degrees. That's the wall of this angle ABC is what? 62,87 degrees. And we can find the theta because ABC, it consists of the theta and the 44,3. It is inside of ABC. So how can we determine our theta? So therefore our theta, it was going to be 62,87 minus, we have to remove the other angle that we are given because these two angles, they add up to that. If we add this theta to 44,3 degrees, we are going to obtain the whole of ABC, which is 62,87 degrees. So you can take this to the other side, which is the one that we are having here. That is to find our theta direct. I don't know what is happening with these pages, guys. So our theta was going to give us 18,57 degrees. That's the theta, the angle to illuminate. That's the one that you are being asked there. So questions can be like that. You see, you have to be careful with your trigonometry as you are revising this. On question number 8, we are given, in the diagram below, we are given a polygon ABEFD. ABFE. This one is AB to E, then to F to D. This one, as it is a polygon which is drawn. AB is produced, which is AD, sorry. This one is produced to the point C that lies on BC. All right, then you are given these two, they are parallel. AC is parallel to FE. So we are given this part of our parallel lines. Then we are given 3x to x, and these are the angles that we are given. 8.1, determine with reasons the numerical value of x. That is, they're asking you to solve for x. How can we solve for x? Which information that we can use where x is given? So x, we can see it in triangle ABC. Remember, ABC is a triangle. And inside of the triangle, we know that these angles, they are supposed to add up to 180 degrees, the interior angles of a triangle. So if I add these angles, 3x plus 2x plus this x that I'm given, I'm supposed to obtain 180 degrees. There we are simply talking about what? Sum of interior angles in a triangle. That is sum of angles in a triangle. They add up to 180 degrees. It's an equation that you have formed. You can solve for this equation. This is the same as 1. So 3 plus 2 plus 1, that was going to give us 6x equal to 180 degrees divided by 6 divided by 6. So our x was going to be 30 degrees. All right, so that is the numerical value of x. So meaning to say this is 30 degrees, 2x, that is 2 times 30, which is 60. 3 times x, 3 times 30, which is what? 3 times 30 is going to be 90 degrees. So meaning to say it's a right angle triangle with this one. It's a right angle triangle. As you can see, there's a 90 degrees there. All right. Then what type of triangle is ABC? Give a reason for your answer. As we can see, guys, these angles, they are different. All three angles, they are different. So this one, it is supposed to be what? A scalene triangle, because we are having what? 3 different angles. There are 3 different angles. So it can be in terms of sides. If you are given sides which are different, 3 different sides, still that's a scalene. Or it can be taken from angles. They can be in terms of angles. If the angles, all of the angles are different, that will be a what? A scalene. 8.2, in the diagram ABC, triangle ABC is drawn, and we are given these sides. AB is equal to BC. Then we are also given angle B1 is equal to angle B3. So prove that angle E1 is equal to angle D2. We want to prove that angle E1, this is our E1, this one, okay, it is equal to D2. This is our D2. So we need to prove that. So how can we prove that these two angles, they are equal? All right. If we are to take a closer look, let's consider what we are given. These two lines, they are equal. These two lines are equal. So what is that we have? It follows that angle A and angle C, they are supposed to be equal. Remember, the angles opposite what? Equal sides. So angle A definitely supposed to be equal to angle C. These are angles opposite what? Angles opposite equal sides. They're supposed to be equal from your isosceles triangle concept. So if angle A is equal to angle C, all right, we have angle A, we have angle B1. Let's say we have these angles, angle A and angle B1. How can we find angle E? We can determine angle E. Remember, this is a triangle, guys. Considering that this is a triangle, remember our concept I talked about this, guys, the exterior angle concept. The exterior angle of a triangle is equal to the sum of the opposite interior angles. The opposite, this angle and this angle added together must give us exterior angle. So if we take a closer look, this is what exactly is happening at angle E. E1 there is the exterior angle of this triangle, this one, of this triangle ABE. It is exterior angle. It is an exterior angle that we have there. It is an exterior angle that we have. So meaning to say angle E1, this angle E1 was going to be the sum of angle A plus the angle B1, the sum of these two. Let's do the same thing on the other angle that we are being given to also show that it is equal, which is angle D2. D2 is also an exterior angle, this one, but of which triangle? Of this triangle now, this triangle, this one. It is an exterior angle. So meaning to say if we add angle C and angle B3, it is the sum of angle C and angle B3. It is the sum of these two. That is what we are given. So there we are using the same reason, the exterior angle of what? Of a triangle. Exterior angle of a triangle. Just going to write in short, exterior angle of what? Of a triangle. It is equal to the sum of the opposite interior angle. So how can we see that angle E1 is equal to angle D1? Because this is not enough. We know that angle A and angle C, they are equal. Angle A, this one, and angle C, remember they are equal. What about angle B1 and B2 and B3? If these two are equal, then it means these two are also equal. If B3 and B1 are equal, are they equal? B3 and B1, they're equal. Remember, we're already given that B1 is equal to what? B3. B1 is equal to angle B3. So this one is already given. It's already given. So these two, they are also equal. Angle B1 and B3 are equal. So therefore, automatically we can say angle E1 is equal to angle D2. Automatically, these two are also equal. There is no way that these two are the same as what we have on the other two there. There is no way. If this is 40, let's say this is 40 and this is 60. This is also 40. This is also 60. 40 plus 60, 100. 40 plus 60, 100. There is no way that these two are equal and the other one is not. So that is, we have proved this. These two are the same. We can see that these two are the same from that situation or that we are given. So that is it, guys. For 5 marks, we can actually leave it like that. On question number 9.1, we are given, that is in the diagram below, we have got a parallelogram. Remember your parallelogram. Opposite sides, they are parallel, and also they are equal. They're not just parallel, but they're parallel and equal. Opposite angles are equal. We do understand that these opposite angles, they are equal. The diagonals bisect each other, this and that. So we're given that. These two are parallel. AD is parallel to BC, as we can see, and also DC parallel to AB, and we are given this one, they intersect at O. Prove that the length of DO and is equal to the length of OB. This one, the length of D to O is equal to O to B. And also prove that AO is equal to OC from A to O, and from, this is the part that I was talking about, that remember in a parallelogram, the diagonals bisect each other, but there we are supposed to prove that truly they do bisect, they're actually the same. So what can we do? If we are to consider congruent figures, they are same in terms of everything. It is best that we work with congruent figures. So we have to figure out which triangles that are congruent, where these lines are, where we have these lines. So we can consider triangle, any triangle. Let's consider this one, where we have the length of DO is there, AO is also there. Where also we can also consider this triangle. We need where we have what? where we have those sides, the sides that we are given there, the sides that we are given. So I'm just going to take also this one, this triangle. Are these two triangles congruent? Because that's where we have these lines A to O. That is, A to O is there. O to C is there. A to O, we talked about this. O to B is there. D to O is there. As you can see, these lines are there. So by proving that these are congruent figures, therefore there is no way, guys, the distance is going to be the same. So how can we prove that they are congruent figures? All right, let's see. What are we having? They are parallel lines, remember? They are parallel lines. So let's talk about angle D and angle B, these two, D1 and D2. As you can see, we are forming a Z. From these two lines, we are forming a Z. So these are alternate angles where we form a Z. And remember, alternate angles are equal. So that is, we've got alternate angles there. These two angles are equal. Angle D1 is equal to angle B2. Okay, we saw that from our alternate angles. We are forming a Z there. These are alternate angles. Since AD is parallel to what? Since AD is parallel to BC. All right, so this angle is equal to this angle. We are proving they're congruent. We want to see they are congruent. What about any other one? These ones are direct, guys. O1 and O3. These are vertically opposite angles. Vertically opposite angles. Vertically opposite angles. Remember that. So O1 of this triangle, all right, angle O1 and O3 of the other triangle, they're equal. There we have got vertically opposite angles. I'm just going to write in short. Do we have any other angle which is equal in value to the other part that we are given? Can we use A1? A1 like this. Here we are forming a Z again. Angle A1 and angle C2. So these angles, they're equal, all of them. So A1 is equal to angle C2. Remember, this is where we have our C2. Alternate angles again. So we talk of alternate angles. AD parallel to what? AD being parallel to BC. So we can see that in this triangle, remember, what are congruent figures? They are the same throughout in terms of everything that you consider, everything. So in terms of the angles, you can talk of angle, all the angles are the same. If you wanted to use the side, you can also use this side AD and the side BC. We can also take that one as to our advantage because it is the same also. So you can use angle side, or you can use angle like that. So it simply follows the triangle DOA, this one, DOA, or triangle AOD, the way that you're gonna, I don't know the way that, as long as you're taking in terms of equal angles. D to O to A, D to O to A is congruent to this triangle BOC. In that order, also BOC to triangle BOC, which is BOC. So if these two are congruent, it means the length also they are the same, guys. If guys, you know, congruent figures, everything is the same. They are not similar. Everything is the same. So it means here we want to prove that OD and what? OB. So this is where we have DO and this one, BO. As you can see, the first part, they are the same. So therefore, we can say OD is equal to what? OB. Which other part? AO and OC. AO, this is OA, this one. OA, the same way that we take is supposed to be the same way, as you can see, the same way as OC. So it means from A to O, it is also the same as O to C. Therefore, this is true. From congruent figures, it follows the length, even the last one that we have from D to A, this one, DA must be equal to BC. If it was given like that, it must be equal to BC from DA. This is the one that we have DA and BC. And as you can see, it is actually proving exactly what we are supposed to have on a parallelogram. These opposite sides are what? Are the same. So proving, guys, so many ways. I think if you work with your Euclidean geometry from the questions that I did on the introductions, I did a lot of questions that you can actually take to your advantage. I talked about this. All right, on 9.2, we are given PQRS is a square. Remember, a square, all sides are the same. This one, so it means the length that we are going to be having, SR is equal to PQ, RQ, it is equal to SP. The sides are the same, and the angles of a square, remember, they are at what? They are at 90 degrees. Know the properties before attempting the question. Just know the basics. So the first question is prove that. All right, there we are given before that, X is the midpoint of SP. SP, so this one, it is the midpoint. All right. Then also, Y is the midpoint of PQ. This Y is also a midpoint. So midpoint meaning to say it is being divided into two. So the first question was to prove that triangle SPY, that is S to P to Y like this triangle here, it is congruent to triangle RSX from R to S like this, from R to S to X like this. This is the triangle they want to prove that they are congruent. So what can we use to prove that they are congruent? Are we having anything equal? All right, so that is, let's see. Remember, you're told that it's a square. So from a square, definitely it means these two sides are equal. The side of SP and this side of SR, they are equal. Okay, so automatically this SP is equal to SR. Remember, a square from the sides of a square. Sides of what? A square. Sides of a square, opposite sides are equal from the properties of a square, remember? So if these two sides are equal, which other part do we have, which is the same? The length also from, remember, this is S to what? S to P. And we take S to R. If we take this one from P to Y, this one, you will see it is the same as from S to X. Remember the issue of the midpoint. We are told that issue of the midpoint. So that's definitely to say, therefore, PY is equal to SX also. Okay? These are sides that we are referring to. What about the angles? If we check inside this triangle, inside of this triangle, there is a 90 degrees at P. Inside this triangle, there is a 90 degrees there at what? At S. So these ones, they are also equal. Angle P is equal to angle S. That is at what? That is equal to 90 degrees. There we are talking about what? Angles of what? Of a square. The interior angles of a square. Interior angles of a square. Interior angles of what? Of a square. These will be 90, 90, 90, 90. So from there, guys, we can see that the two sides, they are the same. Side SP and side SR. We consider side PY, this one, and side SX. We consider the angle, so it can be side angle side, side angle side. So these two can be said they are congruent. So therefore, we can say our triangle SPY is congruent to triangle RSX. This is from what? Side angle side. The case of congruence there is going to be side angle side. We saw that the case is supposed to be indicated. 9.22, given that angle R1, this one, R1 is equal to X. Let's say R1 is X, this one. Identify with reasons another angle equal to X. Guys, we say these two triangles, they are congruent triangles. These two triangles, they are congruent. So to say the angle that is at R there, the angle that is at R, this one, it corresponds with what? With S. So it is supposed to be the same angle that we have at S there, which is S1 inside of this triangle. Remember from our congruent figures, those two, they are supposed to be the same. So we are talking of what? Angle S1. It is also supposed to be X from what? Congruent figures. Since triangle SPY is congruent to triangle RSX, these two angles are equal. Angle S is equal to angle R. That is what they wanted there. Then prove that SY, the line SY, this one, is perpendicular to Rx. This one, Rx. They are perpendicular, meaning to say they meet at 90 degrees. One of these angles is supposed to be 90 degrees. Is it O1? Is it O2? Is it one of these? That is what you're supposed to prove. In order for you to prove that they are perpendicular, simply prove that one of these angles is supposed to be 90 degrees. O1, either O1, either O2, either it's O3, either it's O3, any one of these, either it's one of these that are at this point is supposed to be what? 90 degrees. If we can prove that, we are done. So how can we prove this? All right. We know this is a square, and giving or containing our angles here, the whole of this angle S is 90 degrees. Remember, we can find or we can relate in terms of angle S because we are given something about S. Here we said S1 is what? Is X. Remember, we said this is X. So that's why I'm focusing on there on that point. You can also focus on R there. It's still fine. So if S1 is X and the whole of this S is 90 degrees, remember S, angle S, which is the sum of angle S1 and S2, is equal to 90 degrees. We talked about this, about the interior angles of a triangle. So it means we can determine one of these in terms of X. Remember that angle S1 is X. So if I add S1, which is X, plus S2, it must give us 90 degrees. So it means angle S2 can be obtained in terms of X. S2 is equal to what? 90 degrees. You take the X to the other side, it becomes a minus. So it means this angle S2, which is remaining on this other side, is 90 degrees minus X. Remember, I want to prove any one of these angles. Is it O1? Is it O2? Is it O3? So inside the triangle SOR, using triangle SOR there, using triangle SOR, we know that angles inside of a triangle, they are supposed to add up to 90 degrees. So if we are to find the angle O2, we are supposed to obtain 90 degrees. Remember, O2 is inside of the triangle. So we have two given angles. So how are we going to find O2? From 180 degrees. So it is going to be 180 degrees minus these angles that we are given. Which angles are we given? The two angles, the 90 minus X that we calculated, representing S2, and the X, which is representing R1. Remember, we are told that R1 is equal to what? R1 is equal to X. We are talking about what? Angles in a triangle. This is what? Sum of interior angles in a what? In a triangle. They're supposed to add up to 180. So meaning to say, by subtracting from 180, we are supposed to obtain angle O2. So that's 180 minus, take note, minus X plus X, that's a 0 there. So we are going to remain with what? 90 degrees. So 180 minus 90, that's 90 degrees. So as we can see, guys, O2 is equal to 90 degrees. So definitely it means also O4 is 90 degrees. Definitely it means O3 is also 90 degrees. O1 is also 90 degrees. Vertically opposite angles can justify that. And also angles on a straight line. So that is what I was saying. By just knowing one of these angles, so if we know that there is a 90 degrees there, therefore we are saying these two lines are perpendicular. We cannot say they're perpendicular if there's no, remember 90 degrees, that is to show that the two lines are what? Perpendicular. So therefore we can say the line SY is perpendicular to line RX. SY and RX, they are perpendicular. They meet at 90 degrees. That is to be perpendicular. So this is how our questions can be given as. You just have to revise as much questions as you can in order for you to obtain these 100 marks. So let's continue to revise in light in whatever that we are going to be having in our revisions till we meet again.